we can move on to SegNet. This was an assignment for you to watch this video. Any questions about this one?
Yeah, I had two quick questions about this one. The first one being in the diagram in the upper left, the encoder CNN, that's what you're trying to do the transfer learning on. And so I guess my question really is, that's kind of a simple CNN. So if you're doing transfer learning, like let's say you do ResNet, how are you supposed to transfer the pooling indices when in ResNet you don't have max pooling?
So this one, they are having their own architecture. It's not ResNet.
So do you do any transfer learning in this one?
Yes. So first, you're going to train this part of your neural network yourself on ImageNet, and then you're going to transfer those weights to this task. It's not like you're going to download the weights from somewhere and then fine-tune them. You're going to have to do some pre-training.
I see. So if I were to do this myself, this would be slightly more involved.
Yes, but I guess this neural network should be available online.
Okay. And then
for your work, you can actually download this network, cut it from here, and then reinitialize these weights randomly. And then that's going to be acceptable.
Cool. Thank you. And then my second question was about the softmax at the very end. So I haven't actually messed with segmentation data yet, but the way I've seen it represented in the past is with integers representing the different classes. So if you do a softmax at the end, I'm assuming that's an element-wise softmax that makes all of the pixels in between 0 and 1. So I'm curious how that's translated to the segmentation map.
Oh, no. So it's, I think you are overthinking it. You pick a pixel, that's going to be a vector before the softmax. If you take that single pixel, push it through a softmax, those numbers in that vector are going to turn into probabilities. And then you do it for every single pixel in parallel.
Oh, I see. So if you have 20 classes, for instance, that you could possibly have in your segmentation map, then each pixel before the softmax would be in R20, basically. And then when you did the softmax, it would try to predict the class for each one of those pixels then.
Exactly.
Gotcha. Thank you.
And it's actually going to be 21 because you're taking into account the background. So background is an additional class. Okay. Any other questions? And we saw this idea of using unpooling before when we were doing that deconvolution type neural network. But this is more successful because this is a harder data set and they're able to achieve better results and report better results. The question is, can this be done without transfer learning? It can be done, but there is a chance for your neural network to overfit because here you have less data. You have less data in terms of pairs of images and their corresponding segmentation map because it's a harder task compared to classification. For classification, the labeler is going to look at this image and it's going to say there is car. That's it. But here, the labeler has to look at every single pixel and say, this is a car, this is a road, that's a tree. So you're going to have less data. And whenever you have less data, a deep neural network is more prone to overfitting. That's why you do transfer learning. That's a good question, actually. Any other ones?